previously, we successfully set up inter-VLAN routing, and that's great. In fact, this PC still has the ability to ping the remote server on the 30 network, and he's on the 10 network. But here's our next challenge. Check this out. What if we had 200 clients? So this PC and 199 more devices, and they all are trying to use remote resources. For example, they all go out and they try to download this brand new video off of this server. Well, as they start pulling that video down across the network, if they're all connected at 100 megabits per second, and they're all full duplex because of the switch functionality, we are going to have a bottleneck right here. Now, these two trunk links, they're both 100 megabits, but we're only using one of them, and that's because Spanning Tree is avoiding a loop. Let's go verify that. Over here on switch 2, which is this guy right here, the left switch, let's just issue a show interface trunk and take a look at the trunking that's going on. Here it shows FAs 11 and 12, which is great. That's perfect. It's showing that we're not restricting any VLANs from crossing those trunks. And currently, we have VLANs 1 through 3 that we know about. But check this out. VLANs in Spanning Tree forwarding state and not pruned. We are only forwarding for VLANs 1 through 3 on this top interface, FA1/11. And on the bottom interface, FA1/12, we're blocking. And we could verify that further with a show Spanning Tree for VLAN 2 because we know VLAN 2 exists. And we'll say we want to look at interface FA1/12. And that shows us right here that it is indeed blocking. And there's a lot of other Spanning Tree aspects that we could look at, but for the moment, we're just realizing that we have two physical interfaces, but only one is being used. Now, with fault tolerance, that's a good thing, because if the primary link fails, the other link can pick up and start forwarding traffic, and that's great. However, most people, if you pay for two, you want to be able to use two. For example, if you buy 2 cars, you want to be able to use 2 cars. With firewalls and failover, if you buy 2 firewalls, it'd be great if you could have both of them working. And they call that active-active failover in the ASA department for security and for fault tolerance. Well, we can do the same thing here with Spanning Tree by tricking it. What do you mean, Keith, trick it? We could tell the switches that instead of thinking of these 2 links as 2 separate physical paths, we could tell Spanning Tree to consider them as one giant pipe called an EtherChannel. Now, we can have layer 2 or layer 3 EtherChannels. Here, we're going to change these trunks from layer 2 trunks, which they currently are, and make the switches believe that they're one nice giant layer 2 EtherChannel. So to pull this off, we're going to neutralize effectively these 2 interfaces and set them back to their defaults. And why do I do that every time as a precaution? The reality is these 2 interfaces, if they're both going to belong to a bundle, an EtherChannel bundle, we want to go ahead and make sure they're identical. So in that light, just to err on the side of caution, what I'm going to do is I'm going to do a default configuration, apply the defaults to those 2 interfaces, which will temporarily take out my trunking, but then they'll both be exactly the same. That's probably the number one cause when people try to set up EtherChannel groups, is that they don't have the 2 interfaces. Maybe one's configured as an access port, the other's configured as a trunk, and as a result, they don't pan out. So the very first thing we're going to do is I'm going to go in and do a default interface range for Fast Ethernet 1/11 through 12. And that'll take these 2 interfaces and it'll basically wipe them back to factory defaults. Now, once that's done, I'm then going to go ahead and configure those 2 interfaces by specifying I'm going to do a shutdown. Why? Because it's also helpful if we bring them down, do our configuration, then bring them up. That's also helpful in getting the EtherChannel to work successfully the first time. So here's the default interface range for those 2 interfaces. And now that that's done, we're going to get a little hissy message from the other side because we currently were trunks and now we're not. We're getting BPDs from the other side, and that's okay. So our next step is we're going, now that they're all defaulted, I'm going to shut down those 2 interfaces and I'm going to specify that they both belong to channel group number 1. Now, channel group number 1 doesn't exist yet. I'm just creating it out of thin air. And the various modes that are available, we can have active or desirable, and there's different channel negotiation protocols. One's proprietary from Cisco called PAGP, one's an open standard called LACP, but here I'm just going to specify that I want it to be on. I want them to be a part of channel group 1. And now we have this brand new interface. And this interface is called interface port channel number 1. And we can treat it just like any other logical interface. So if we want to configure a trunk, because right now they're both a member of that port channel number 1, but they're not configured for trunking. So to fix that, we simply go back into interface port channel 1, which we actually haven't been into yet. We created the port channel group 1. Now we'll go into interface config for it and say switch port mode trunk. So we've done two major things. Number 1, we've specified that the two interfaces belong to port channel 1. And number 2, we told port channel 1 that it's going to be a trunk. And that's it. Now the rest of this is configuring the other sides. So on switch 1 in the middle here, we'd have to configure these two ports and these two ports as port channel groups. We'll put these guys in port channel 1 and these guys in port channel 2. And then we'd also have to specify a port channel group for 13 and 14 over here on switch 3 on the far right. Now for me, one of the toughest parts of configuring EtherChannel is to make sure I'm on the console of the right device. So the middle switch right here is where we're going to go ahead and configure next. So oftentimes I'll put a config in, I'll type away and I'm on the wrong device. It's so painful. I make extra care that I'm on the right device at the right time. So this middle switch, which is switch number 1 from our previous 3 videos, we're going to go ahead and configure ports 11, 12, 13, and 14 as EtherChannel. And we'll put 11 and 12 into port channel 1 and 13 and 14 to port channel 2. So pretty straightforward. We'll go into configuration mode. I'm going to default the interfaces just to make sure that everything about 11, 12, 13, and 14 is identical. And once that's completely wiped out, we'll then go into 11 and 12. We'll shut them down, configure them to both be in channel group 1, and we'll specify mode on, so we're not negotiating the channel group whatsoever. And then I'm going to do a no shut to bring them out of shutdown state. I'm going to do the same exact behavior for interface 13 and 14, except I'm going to put them in a different channel group. I'm going to put them in channel group 2. So just like creating sub interfaces, you can use any number you want. Same with channel groups. You can just pick them out of the air and use what you want to use. So once we've assigned 11, 12, 13, and 14 to channel groups, we're then going to go into interface for port channel 1, tell it that we want it to be a trunk. It contains interfaces 11, 12. And we're going to do the same thing for port channel interface port channel 2 and tell it that we want it to be a trunk. Now these big blue circles are representing the logical interface or the port channel. So we have a port channel between these two switches, which is switch 2 and switch 1, and we have a port channel or will between switch 1 here and switch 3 on the right. So switch 1 is done. The only thing we have left is switch number 3. So let's go ahead and configure switch number 3 right now. Again, getting to the right device is half the battle. So on switch 3, we'll go into configuration mode. We'll default interfaces 13 and 14. That's these guys right here on this right switch. And we'll shut down the interfaces just as a good practice. See, sometimes if it takes like 5 minutes to configure one side, then you go to the other side, you might have some error disable states where the interfaces time out because they're trying to negotiate. So doing a shut and a no shut gives you a nice clean ability to work with that EtherChannel without the risk of going into error disable, as it doesn't take as long if you do the shut and the no shut to turn them on at the same time. In fact, ideally, we would configure both sides, switch 3 and switch 1. And then the final step, go back and just do a no shut at that moment on the interfaces involved. So this looks pretty good. What steps did we do? Besides defaulting the interfaces, check it out. All we really did is we told the interfaces that we want them to become members of the EtherChannel group. So that is right here. So right here, this command, channel group 2 mode on in interface configuration mode, told these two interfaces they belong to the channel group. And then we went into the interface for that channel group right here. And we said we want you to go ahead and become a trunk right there. So really, we're looking at two basic commands. Interface config, channel group 2 mode on, and then in the interface of the channel group itself, switch port mode trunk. So let's verify that this is all working. Let's go back to switch 2. Now earlier, let's scroll up and take a look at our show interface trunk from earlier. Earlier, we had 2 trunk ports, FA1/11 and 12, and we were only forwarding on 11. 12 wasn't being used because it was being blocked because of spanning tree. If we now issue that same exact command, I'll go up in the history a little bit, and show interface trunk, take a look at this. Now it shows one logical interface. That's our port channel group that we created. Its trunking is on because we told it to trunk. It's using 802.1q. The native VLAN hasn't changed from the defaults. Also, take a look at this. We are forwarding on port channel 1, and we're no longer blocking. So the spanning tree is forwarding, and the internal load balancing is being done by the EtherChannel itself. And one last thing here, how do we verify the status of our ether channels? Because there's lots of variables that might cause these ether channels to not work. Well, one test is we could verify that our pings still work through the network. And hopefully they will. So what happened here is that when we shut down those interfaces, those trunks, and reset, we must have lost some ARPs on the virtual interfaces on this middle switch, because that's what that represents right there. If we did another ping, we should have 100% success. Also, if we tried to ping right away, spanning tree in its default configuration may take up to 30 seconds to allow frames to be forwarded on ports or trunks that just came up. So another thing we can do to verify the ether channel, besides the functionality working, is we can do a show ether channel summary. And show ether channel summary will show us our ether channel groups. Here we have PO1 for a port channel. And we have SU. What does that mean? Capital S and capital U. Well, the capital S is right here, means it's a layer 2 ether channel as opposed to a layer 3 ether channel. And the U, capital U, means it's in use. We're currently up and active. And then we have the 2 members of that ether channel, which are FA1/11 and 1/12. And P represents in port channel, meaning they're members of the port channel. And that's it. So that's a great way to help maximize the throughput on our networks, and we could have multiple interfaces. You could have 4 or 8 interfaces, and they don't have to be just fast Ethernet. You could have gigabit interfaces. So if you had 8 gigabit links back to back between 2 switches, you could effectively put them all into one bundle and have all that throughput as one logical pipe, and spanning tree wouldn't care a bit. I appreciate you watching. It's been a lot of fun, and best wishes to everybody in your studies.